Hello and welcome, everybody. We are live on our Kotlin channel, and today we are talking about Kotlin for WebAssembly. And I'm Anton Arhipov, and I'm a developer advocate at JetBrains. And today, with me here, I have Zalim, who is leading the efforts up on Kotlin for WebAssembly, and he's going to talk about the latest and greatest today. So, hello, Zalim.
Hi everyone, hi Anton, nice to see you.
Likewise, we have Kotlin for WebAssembly goes alpha blog post at the screen. So you probably wanted to say something about it?
Uh, yeah, sure. Uh, recently we moved Kotlin WebAssembly to alpha stage. So we're super happy, we're super excited with it, and we want to share what is Kotlin, what is WebAssembly, and how powerful it is together.
Nice. So alpha status means that basically it's possible to try, right? So you're going to show us today how to try Kotlin with WebAssembly.
Yeah, as we say it, it's ready for using in pre-production scenarios, and we encourage our users, to try it and give us feedback. Your feedback is super important at this stage. Uh, it will. Uh, uh, I- Depending on your feedback, we prioritize things. We'll make decisions. So yeah, give it a try and share your feedback.
Nice. So, folks, you can ask your questions in the chat, and you can give us a thumb up in your like on the button below, and subscribe to the channel as well. It will help us to make great content further on. Let me know in the chat where are you from, and if you have tried Kotlin for anything, and if you're familiar with WebAssembly, that's actually interesting to hear. For us, how many of you have tried WebAssembly and for what? And with that, I'm going to give the stage to you, Zalim, and show us the cool stuff that you have worked on.
Yeah, thank you. Again, feel free to drop your questions, comments to the chat right now. During our today's stream, we will try to answer as much as possible, and join our WebAssembly channel in the Slack, and feel free to ask any questions or to get help there, to get future updates. It's the best place to get uh, help or updates about Kotlin WebAssembly today. Uh, so let's start. Uh, so today we'll talk about Kotlin Wasm and how powerful, how we can use it in cross-platform environments. So before we start, I'd like to set up some common context because it's important. We are on Kotlin channel on YouTube, and probably most of folks know about JetBrains, about Kotlin, but may we may have some other folks who not so familiar about Kotlin and history of Kotlin. So just to make sure, I want to set up quickly, super quickly, actually, set up. So JetBrains is a company working on developer tools. There is a bunch of IDEs. There is team tools like issue tracker or for CI/CD, and of course Kotlin. Kotlin is a programming language developed by JetBrains. Uh, it's a modern programming language. It's well known with its null safety. Uh, null safety is uh, $1 billion mistake what Kotlin was aimed to fix. Kotlin statically typed language. It's modern language which concise and expressive. Kotlin has different targets. It's cross-platform technology. We have JVM. We have native targets. Under hood, native is targeting many platforms like iOS, Linux, and so on. We have a compiler for JavaScript, and recently this year we announced WebAssembly as experimental, and last week we switched WebAssembly. We moved to alpha stage. One thing what I love about Kotlin is what it is firstly pragmatic, and there is a lot of fun. So, what is WebAssembly? WebAssembly is binary instruction format for stack-based virtual machine. There is key properties of WebAssembly like it's platform and CPU independent. It is designed to provide good and predictable performance with both baseline compiler and showing great peak performance with optimizing compiler. One notice here, for example, what WebAssembly was designed for example, to get streaming compilation. What does it mean? When you download your WebAssembly binary, there is a streaming compiler, quick compiler, baseline compiler, which able to compile your WebAssembly binary to executable in parallel of downloading. So when you finish your downloading, when browser finished downloading your Wasm binary, it already has something to run, not with peak performance, but comparing to JavaScript, it's a big move. Because with JavaScript, for example, you firstly need to download things, parse it, and after that you can start compiling. It is it allow you to start your application quicker. Another property of WebAssembly is safety. Safety and good isolation make WebAssembly great in many cases, not only for browsers. For example, for writing plugins or running untrusted code, as we have a lot of untrusted code actually inside browser. And last not least is what WebAssembly designed to be efficient in terms of size, decoding, and compiling. As I mentioned before about compiling, what it's designed to be compiled during downloading, for example. So is WebAssembly for web, or is it assembly? There is a joke about WebAssembly. What it is never. It's not web nor assembly because yeah, if that's true. WebAssembly originally was born for web. Maybe more precisely to say. It was designed with web needs in mind, but not only web needs was taken during these design decisions. Working group actually quickly discovered that it could be something bigger than just web technology, and nowadays it's used in wide range of environments. Of course, inside browsers, but outside of browser, there is usages in cloud, for edge computing, in mobile technologies, for embedding inside blockchain technologies, and on desktop for developing operating systems, for developing and for application or inside your operating system, like using WebAssembly as format for your applications, for like distribution format, universal multi-platform, platform independent format for applications. So WebAssembly is great technology with great future. It's the future of building web applications with Kotlin, I think. Recently, recently we promote Kotlin Wasm to alpha. As you see, if you've seen before, there is great blog post by Seb. So what alpha mean? Kotlin Wasm is ready to use in pre-production scenarios. We again encourage you to give it a try. We need your feedback for further development. So yeah, um, during this year, we did a lot of work to make it better for usage. We, of course, from day one, it was part of Kotlin multi-platform story. Um, with multi-platform Grader plugin, with multi-platform tools, it's only way to use Kotlin Wasm. We have support with build tools. We have some debugger support. During this year, it was improved a bit. You can debug your Kotlin Wasm program inside the browser. You can put breakpoint. Your program will stop. You can watch your variables. You can see your stack traces. And of course, as a tooling company, what develop a lot of different IDEs, IDE is a big part of this story. IDE support is great for Kotlin Wasm as well. Kotlin Wasm depending on few proposals. We from day one we decided to use garbage collection proposal and typed function references. Also, we used exception handling proposal. Recently, I think about 2 months ago, garbage collection and typed function references become stable, moved to phase 4, and during these 2 months, more and more browsers shipped it turned on by default. Also, we use extend name section for debugging propose. So today it already works by default in major browsers like Chrome, Chromium-based browsers, and Firefox. There is no support for inside Safari yet. There is some work in progress, and a few days ago I checked it, and as for today, JavaScript core passes 99% of our compile tests. So the future where we have support inside Safari is very close. JavaScript core it is virtual machine inside Safari, and WebKit what aimed to run JavaScript and WebAssembly. Aside of that, what happened this year? We worked closely with library authors inside JetBrains, and outside of JetBrains, many libraries got WebAssembly support, official Kotlin Wasm target, and many of them already available in Maven Central. Namely, it is like Kotlin X, coroutine, serialization, I/O, datetime, and so on. Of course, Compose Multiplatform. It's not limited by our JetBrains libraries. There is libraries developed by community like OKIO, Decompose, and others, what already has uh, WebAssembly target and publish it to WebAssembly. So if you're developing some Kotlin library, Kotlin multi-platform library, it's time to add WebAssembly target there and join to this activity. Um, it shouldn't be super hard, especially if you already have JavaScript target inside your library. It should be super easy to get Wasm.js target based on what you already have for JavaScript target, or uh, in our case, for example, if your library um, fully Kotlin multi-platform, pure Kotlin, it should be also super easy as we have with Kotlin immutable collections, for example, which is pure Kotlin library. It was super easy to adding Wasm.js target as well as Wasm YC target. If you just using other libraries, Kotlin multi-platform libraries, it's time to encourage uh, library offers you use to add WebAssembly target. Uh, yeah. Next, so now we have Kotlin Wasm as alpha, and we with Kotlin Wasm, we are working on two major use cases for now. First is creating web browser applications with Compose Multiplatform to allow developing and porting applications using Compose for UI. And second use case is serverless and edge computing, including cloud functions, lambdas, workers, and so on. To leverage WebAssembly portability and efficiency benefits on server side. Let's talk about Compose Multiplatform. It is Jetpack Compose decorative UI toolkit in Kotlin developed by Google for Android. Some time ago, a team inside JetBrains took it and make it multi-platform, and it allows writing and share UI between Android, desktop, iOS, and web. On web, it uses Kotlin Wasm. Here we have Jetpack JetSnake application from Jetpack Compose examples compiled to WebAssembly and run inside browser. We can go to the page and look at how it works. It's works similar to usual web applications. You can scroll. Everything's as in original application. Another great example, we can look here. It's yeah, creative. Probably it's my first application what I ported. Not I didn't write everything here, but I just ported, take sources as is, and maybe with some minor fixes, port it and run inside browser. It is demo application developed by Anton and maybe someone else during on some streaming. Yeah, it's for creative works. Maybe you have seen some works done by Anton with circles by Anton. Yeah, it's nice. Let's move on. So yeah, why Kotlin Wasm? The main benefit of using WebAssembly for Compose application is performance. According to Compose benchmarks, Kotlin Wasm version show close to native performance and close to it's about 2 times better compared to Kotlin JS. It's it's a bit slower than Kotlin JVM, but I believe there is a big room for improvements. Even now, in some number crunching micro benchmarks, Kotlin Wasm can show performance comparable to WebAssembly. Uh, so, yeah, you can clearly see on diagrams how fast it is, and yeah, I believe there is big room for improvements, and we can get uh, i- we can get web applications with experience with performance close to applications run on desktop with JVM.
All right. I think can we address actually a couple of questions
Yeah,
here? It
sure.
makes sense. Um, there was a question about garbage collection availability for the major browsers. I
Mm,
think it's not that we are implementing it ourselves, right?
yeah.
It's implemented by the browser vendors, but do you have any information on that? Probably.
Uh, yeah, it's as I mentioned, garbage collection proposal is finalized, and it's uh, yeah, it will not be changed anymore in terms of this MVP proposal. It's on final stage, and at least two major browsers, Firefox and Chrome, already implemented final version and turned on it by default. So if you download the latest browsers of Chrome on Chromium-based browsers uh, and Firefox, it will be work out of the box. Uh, Namely, it works since Chrome 119, and for Firefox it's 120, I think. Uh, I think only one major browser left. It is Safari. Uh, I mean, by measure, I mean in term of usages. There is biggest browser in the market is Chrome, and next probably Firefox and Safari. There is a bunch of browsers based on Chromium.
All right.
Is it clear?
Yeah, totally. I hope the users, the folks did get the answer. There are some other questions, but I think you will address them anyway. So let's go further. Let's continue.
Okay. Uh, so uh, not only WebAssembly is great technology, and it's not limited by browsers, by browser use cases. There are a lot of projects using WebAssembly outside of browser. Uh, we think it has big potential on server side, specifically on Lambda-like cases like workers or edge computing. So uh, let's speak about YZ. It seems like WebAssembly is rarely used outside of browser without YZ. YZ is stand for WebAssembly System Interface uh, for uh, for serverless, and uh, so yeah. Recently, we introduced WYSI support, and it worked out of the box since 1.9.20. Right now, we are using WYSI Preview 1. Uh, it's remind you what we showed. To run Kotlin Wasm, you need a virtual machine supporting garbage collection proposal and exception handler proposals. Right now, outside of browser, there is Node.js and Deno support. With such support, it's not pure WebAssembly virtual machine, but along with JavaScript, with virtual machines able to run your WebAssembly, and it works well with Kotlin Wasm. Uh, Standalone VMs like Wasm Edge, Wasm Time, and Whammer are working on GC support as well. I I hope we will get some support soon, and we will be able to run Kotlin Wasm in these VMs without any JavaScript support. Uh, so what's next with WYSI support in Kotlin Wasm? Uh, First is we waiting those standalone VMs to be able running Kotlin Wasm there. We work we cooperating with some of VM vendors to help them with this activity. Next step is WASI preview tool and component model. Component model, in my opinion, is next big thing in WebAssembly ecosystem. It's it allows to write different components in different languages and combine them at runtime um, to write application. Component model uh, give you additionally security capabilities, and WASI preview tool built on top of component model, and these two together next big thing what we want to support in terms of WASI. So how to try Kotlin Wasm today? Uh, I think the easiest way to try Kotlin Wasm in action is using our online playground. Uh, so since all major browsers already supports out of the box WebAssembly. It just works. You don't need to do anything. Yeah, you can go with this short link, and you get preset up Kotlin Playground and push play. After some time, it will be what happening now. It compiled on the server. This code sent to our compiler server, and browser gets a piece of JavaScript and WebAssembly code, and this code run inside your browser.
How can we see that actually? Is it possible to
Okay,
see that it actually executes in the browser?
it's it's good question. It's tricky. Uh, Usually, you don't need to do something like that, but we can do some trick here. Like there's JavaScript, and JavaScript language has uh, some special statement called debugger, which say stop my program here. So we can use this. We use actually, so it's kind of interrupt with JavaScript. Kotlin was able to interrupt with JavaScript. We use this ability, write a piece of JavaScript here and say our browser stop my code here, and let's stop here. And we need to go to our browser. Yeah, let's compile something. You can see our request to our server. Okay, let's make it a bit less, because it's hard to calculate this Ackermann function. It's a lot of recursive calls when you open DevTools. Yeah, it run less optimized code. So yeah, we at first time we get exception in this reason. So you can see maybe it's too small. Is it
It,
okay
it
now?
is it is quite small. Yeah. Now it's a bit better, but if you make it slightly bigger, it will be better. Yeah.
It's okay now. Okay. Yeah, as you see, we stopped here. This is original JavaScript piece of code we are writing. Uh, we right now we in JavaScript, but on the left side we can see our stack trace. It's highly optimized and master function hardly recognizable. His main function. We can see WebAssembly bytecode in text representation, decompiled WebAssembly actually inside the browser. Um, so uh, with this function where actually we code this debug function. Um, since it's highly optimized, we hardly recognize function names, variable names, but uh, with some debug information, we could see variable names here, but we can recognize what we, 3 is first argument, 8 is yeah, second argument. I think it is result t, and it is how much time we spent. Uh, yeah. Now we can show. Do you believe me now?
I do. Is it possible to step over the lines of code somehow?
Uh, yes, I think so. But uh, it's not super convenient to debug uh, over bytecode if you not develop compiler itself. Mm, I think users will probably to debug over Kotlin code. Um, I think a few minutes later, I will show how to debug Kotlin code, how we can see uh, uh, same things but over Kotlin code. Yeah, as you can see, you can step over bytecodes.
Okay.
Sometimes
Mhm.
it's useful. So actually, the compiler in Home is super nice, and what at least if you did develop compiler, compiling to WebAssembly is super useful when something
Okay.
go wrong. But normally, I think we want to provide debugging over Kotlin source code. So it's back. Uh, so what's next? Uh, what if we had a Compose support in online playground? So you can easily prototype and share Compose UI, your Compose components inside browser. Sounds nice, isn't it?
I
What do you
think
think?
it would be very productive. I could change my code and immediately see the preview.
Yeah, it's something what we thinking about, and likely we want to implement it. Mm, no ETE for now. Stay tuned.
All right.
Let's move. And another way to try Kotlin Wasm today is our GitHub repository with bunch of examples. You can use this short link and open it. You have these great images with those examples. We can go to GitHub. It is just GitHub repository with separate directories with for each example. You can navigate to each example and show basic information about example like image, what is that, how to run. Usually you need to open this directory and run Gradle task to run this application. Uh, Same with JetSnack example. Uh, so let's try these examples. Yeah. So yeah. Okay. Let's start from browser example. We have super simple browser example. Uh, so yeah, we have main function inside main function. Yeah, by the way, um, out of a box we have a predefined API for many browser APIs, including DOM API. So you can just easily start working with DOM API out of the box. Like we have document, it is yeah, it is document with a bunch of APIs. It was generated from real browser specifications, so it should be good and have everything existed. Aside of that, we have some uh, extension functions what could help during working. Yeah, by the way, speaking about browser experience, you can see how it works inside uh, about AD experience. Sorry, uh, you have completion. When you type something wrongly, you quickly get error. Um, and what else? Yeah, it's just example which uh, uh, starting from empty HTML page. Here's some stylings. It is boring in case you don't have WebAssembly support, but basically it is empty body. So we start from empty body. We create a div element and add some text, some elements. Later we use this input box, and yeah, let's look what we get. Here it is a simple application with input and with some text. We can edit this text when we change this value. It we have events. What we are working, yeah, when we change something, we call our update function with current input element and uh, output element. Inside the update time, we do simple things. We're trying to show progress bar, but right now we have super fast internet connection, so we just don't see this progress bar. Aside of that, we make fetch fetch request to some server. Fetch API, it's a built-in browser API. After fetch, we get result. If it's okay, we try to show this result as you seen. It show the time in requested time zone. Um, yeah, we can do we can add some throttling and it allow us to see this progress bar if you want.
All right. But I have a question.
Yep.
So the entry point to the program is always the main function.
Uh, yes. Yeah.
Is it a convention? Like I did some programming in JavaScript. I remember that you don't really have a concept of the main function when you're developing for the browsers.
Um, yeah. In Kotlin, we don't have an ability to write code on top level in comparison with JavaScript, except Kotlin scripts.
Yeah.
Uh, yeah, and yeah, main function is a way to start your application in this case.
All right. There is a question related to that
Hmm.
about from Abdul, like wondering why the main function does not show run in Wasm.js main. It works in JS main. I'm not sure if you understand the question.
Uh, Let me think. Sorry, I didn't get it.
Yeah. Maybe Abdul, you should clarify the question a little bit. There is another. Aha. I mean the run button, the good icon.
Okay. uh, it's yeah, it's tricky. I think we don't have such a run button in the gutter for even for JavaScript. It's a tricky question for JavaScript and WebAssembly because in comparison to uh, JVM, for example, on JVM you can have many different main functions, and in ID uh, you can choose which one you want to run right now. If you have many main functions in your WebAssembly web application, which one you want to run? It's tricky question. I can't say it's unsolvable. Uh, we just need to think about it, how we can provide the best experience with that, and how to make it clear for users.
Right. There's another interesting question that you probably are getting to anyway, but I'm going to add that. So, Cliff is asking if we should use HTML layouts or we can use box and column and so on. I guess it goes into the compose story. So,
Mhm,
like currently, this example is about just HTML and interacting with DOM, but
mhm.
compose is different, right?
Yeah, that's right. It's just a super basic example how to do something inside browser. Uh, it mostly show how to use different browser APIs from WebAssembly, not only DOM API but Fetch API. You likely need uh, it. Fetch API will be useful in both cases if you work with DOM API or with Compose. But the best way to write web applications with WebAssembly is Compose, and we will look at it a bit later. Uh, Before that, do we have other questions?
Yeah, just a single one. There are more, but I'm not just going to stop here. Just a single one. This does it do the same as JS, like running in HTML file like HTML? Okay, that's cryptic, but we can probably decipher somehow.
Uh, I guess it's about embedding some piece of code inside the HTML file. Uh, if so, it's not something what we supporting. Uh, Uh, Technically, it's possible, but it's different experience. I mean, in Kotlin, we uh, experience what we usually expect. What we provide is having a bunch of file inside project. So all these files compiled together. When you put some piece of code to separately, uh, it, question is it some isolated model? Probably we need to compile separate code fragments, and we need to link them together at runtime. um, I just not sure what it is, something what we want to use in production. In production, we're probably trying to separate our UI from our logic, and we're trying to, you know, uh, to write everything. If we write in Kotlin, we try to write in Kotlin files. E- Even with JavaScript, I don't think it is uh, something what usually used in production applications. Maybe it's used for quick setup for set up your environment to run your application.
Okay. All right. I think let's move on. I'm excited to see how it looks with Compose actually.
Yeah, before we go to Compose about debugger, yeah, here in this case, we already see Kotlin code. Mm, so I know let's hook, put breakpoint here or here and write something. Yeah, as you see, we stopped our breakpoint. Is everything visible? It's okay.
So this looks like magic. You have Kotlin code visible in a browser somewhere in the console, right? And you're actually
Yeah,
executing WebAssembly bytecode in the browser. So how does it work? So the people understand. Does it use source maps somehow? How do you map
yeah,
the source lines to the bytecode that is running somewhere?
yeah. Sorry. Uh, that's right. And how do we generate web source maps? Virtual machine inside browser, dev tools inside browser can understand how map WebAssembly instructions to Kotlin sources. So with this mapping, we can easily uh, show Kotlin code. We can put breakpoints. Since it's not optimized but development build, we can see variable names, values. Also, we see stack trace and name of functions. We have here some lambdas. Here's go back from somewhere from JavaScript. Yeah, so let's go back to update. We can jump mm, more deeper, and yeah.
Nice,
You,
but this source map is then somehow produced automatically during the build time and packaged into this final binary that is delivered to the browser.
uh, source map generated during development builds automatically. There is some you can see setups in our project. There is some setup of Webpack to uh, we in this case we need to provide to browser not only static files, but we need to provide our sources. Aside of that, everything is understandable for browser. We have static files, JavaScript, WebAssembly, and source maps. We can find everything here. Yeah, here is static files produced by compiler, a bunch of JavaScript files, WebAssembly. Here we see source map file, and aside of that, browser needs to access to source maps. So in development, we have configuration which say also give access to access browser to sources, and yeah, at the end it allow browser to show Kotlin sources. Of course, you can use other ways um, to show sources, to distribute your sources to the browser. It's one way. Uh,
Okay.
yeah. What? Yeah. Let's remove breakpoints. Let me check what else we need to look here. Okay, let's move to other examples. So we have yeah, just snack example. Oh, yeah. let's back for 1 second. You may didn't notice when I started our build, I used the -t option, which is uh, run our Gradle with continuous build. And if we change something here, it will be Gradle automatically will watching your source files and will recompile your code, and the bug will update after success recompilation. The bug will update code. Let's I don't know, write something. So it's recompiled, and we see it's changed. It's just a
Nice.
convenient trick. Uh, okay,
Perfect.
so, something broken. Okay, never mind. Next, switch to JetSnack example. Yeah, here we have JetSnack example, big medium size probably Android application what we some time ago ported to run inside browser, and most of code actually is shared. You can see his small WebAssembly specific parts, and big part of application is located in common code. His yeah enter point here, and yeah, as asked before, when you write a Compose application, of course you use Compose directives, Compose building blocks. Here we have composable functions. We can go somewhere deeper, probably like button bar, navigation. So we have tabs here. As you can see, it's typical Compose application with boxes, layouts, modifiers, and so on and so on. Let's let's run it and look it in action. Let's run it. Yeah. So in this case, it's run from sources on localhost, not something what available in internet. Yeah.
So
Okay.
and is it possible to then debug it from your IDE? Like you work with the code in the IDE, but the application runs in the browser, and you would be able to inspect the stack as if you are working with the JVM.
Not yet. That's
Not
good
yet.
question. It's not available yet. We considering supporting debugging experience inside our IDEs. Right now, it work only inside browser.
I see.
If you have if you users folks who viewing it right now, if you have some preference, some opinion about that, it's super valuable for us. Share your opinion to us. Would you prefer to debug your Compose applications inside IDE, inside browser, both, or something else?
I see. I would upvote this feature request myself. I would prefer to debug inside IntelliJ.
Okay, I see you. So yeah. Mm, what 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 else? Uh, about ID, we we have seen many things. I think about Compose. That's it. One more example. I think last example. Um, Aside of yeah, a basic ID experience with completion, with quick errors, highlights, and so on. We have an ability to run your tests, WebAssembly tests run inside IDE and show results as well. 1 second, let me run our tests. Yeah, as you can see, we have results of our tests. Some of tests successful, some have failed. We see stack traces, text of message after failing. Um, some things uh, not how we want to. Yeah, yeah, there is a big. Of course, as usual, there is things what we need to improve. Even here, we see some strange paths. We of course going to improve, but basically you see what happened, where it was happened, function names. So it's it make debugging your tests super much more convenient, in my opinion.
Nice.
Uh,
Cool.
so I think that's it about ADs. So let's move back. Yeah. Next, I think last but not least, way to try Compose not Compose Multiplatform. Kotlin Wasm is using our Kotlin Multiplatform wizard. Recently, uh, Kotlin Multiplatform wizard added uh, web support. It's still experimental. You can go with this link and you'll see something like this. And here we have this one experimental web compose for web, still experimental itself, but Kotlin Wasm is alpha. Yeah, you can check this one. Can I don't know name your application, super big application, your project ID. After that, you can download. You get some zip file, and you can unpack this zip file and open in your IDE. I know it is IntelliJ IDE or Fleet, whatever, and you get same experience we had with other projects right now. Uh, let's move back to our slides. So, uh, yeah, basically that's it. What I say is give Kotlin Wasm a try. Visit kotlin.in/wasm. Join our WebAssembly channel in Kotlin Slack for future updates or discussions or to get help with something. Um, Also, of course, you can find me in social networks by my last name. Don't hesitate to ask me or in our Slack channels anything about Kotlin and WebAssembly. We are here to help you, and we waiting your feedback. Thank you. Thank you for your time.
Cool. So we have some questions still pending in the chat, and there was one about the hot module replacement, which isn't it the same thing that you showed when you were changing the value of the string, or is it something different?
Uh, it's something different. It's hot topic. I have to say. Uh, yeah, hot model replacement is it used usually in front end development. It's about mm, uh, you can update your code and on browser side you get some notification and with this notification you can save your state. After that your code is updated and you notified and you restore your state. It how it works usually. uh, right now it's not possible with okay with now maybe it's it should work with Webpack as you do usually in front end, uh, but it should be tricky to combine it with Compose. I think we didn't try that. Uh, we mostly think about something a bit different. We dreaming about experience what we have in JVM with uh, hot rewarding. We have in some cases we have some calls experience on Android, as I know. Mm, there is some cases covered. So general idea is you edited your code, you change some, I know, some titles, and without losing your state, your view is updated. Uh, Comparing to a hot model replacement, what we usually see on front end, what I like of this solution is, as user, you don't need to do anything. You don't need to worry about saving and restoring your state. If we do some hot reloading, I think it is the way how we should go, and we probably we try it. Yeah. Uh, Again, I can't say when we will have such thing. It's mm, it's quite tricky to implement that, especially with WebAssembly. Uh, but it is somewhere inside our plans. Eh,
I see. I see. So, folks, if you have if you liked the webinar, if you like the session, give us a thumb up and subscribe to the channel. You should try the examples, so they are available on this link. There, I have it on the screen. And without further ado, I think we can wrap it up here. And thank you, Zalim, for coming and showing it to us. And
Thank
have a
you
nice
for
Kotlin,
asking.
everybody.
When I Kotlin, see you.